Chapter 1.10.10 Resource Bin Packing. Summary. In Cube Scheduler's Node Resources Fit, two strategies support resource bin packing. Most allocated and requested to capacity ratio, allowing efficient allocation of resources based on utilization and capacity ratios. Most allocated strategy scores nodes with higher resource allocations by assigning weights. Requested to capacity ratio favors efficient extended resource usage through configurable parameters, optimizing scarce resources in large clusters based on request to capacity ratios. Resource bin packing. The Cube Scheduler's Node Resources Fit plugin uses two strategies, most allocated and requested to capacity ratio, to efficiently pack resources like a jigsaw puzzle, ensuring optimal use of resources. Enabling bin packing using most allocated strategy. This code snippet defines the configuration for the Node Resources Fit plugin in the Cube Scheduler. It sets the scoring strategy to most allocated for resources like CPU, memory, and custom resources with specified weights. This configuration enables bin packing of resources based on the most allocated strategy. The most allocated strategy prioritizes nodes with high resource usage by scoring them based on allocation levels. Users can adjust the influence of each resource type on the node score by setting weights. This strategy can be configured for the Node Resources Fit plugin through specific scheduler settings. For additional information about other parameters and their default configurations, you can consult the API documentation for Node Resources Fit args. Enabling bin packing using requested to capacity ratio. The code snippet defines a configuration for the Node Resources Fit plugin with the scoring strategy set to requested to capacity ratio. It specifies two utilization to score mappings for the intel.com/foo and intel.com/bar resources, where 0% utilization maps to a score of 0 and 100% utilization maps to a score of 10, affecting how nodes are scored based on the ratio of requested resources to the total capacity. This code defines the scoring shape for the requested to capacity ratio strategy in the Node Resources Fit plugin. It specifies two utilization score pairs, where a utilization of 0 corresponds to a score of 0 and a utilization of 100 corresponds to a score of 10. This code snippet defines two utilization to score mappings. For utilization of 0, the score is set to 10, and for utilization of 100, the score is set to 0. This configuration is used in the requested to capacity ratio strategy to calculate the score based on the ratio of requested resources to total capacity. This code snippet defines the resources CPU and memory with weights of 1 each, indicating their importance in influencing node scoring during resource bin packing. This code defines the weights of different resources for scoring nodes in the Cube Scheduler plugin configuration for bin packing. The intel.com/foo resource has a weight of 5, CPU has a weight of 3, and memory has a weight of 1. These weights determine the importance of each resource in scoring the nodes for resource allocation. This configuration assigns a weight of 2 to the resource. Intel.com/foo. It specifies a memory of 256 megabytes and assigns a weight of 1 to both the CPU and memory resources. This code snippet assigns the highest weight, 5, to the resource named intel.com/foo, followed by a weight of 3 for the CPU resource and 1 for memory. This suggests that the scheduling decisions heavily prioritize the availability and allocation of the intel.com/foo resource over CPU and memory resources. The code snippet is displaying the available and used resources. 4 units of intel.com/foo, 1 GB of memory, and 8 units of CPU are available. From the used resources, 1 unit of intel.com/foo, 256 megabytes of memory, and 1 unit of CPU have been utilized. The code calculates the scoring for the resource. Intel.com/foo based on the available capacity and the requested and used resources. It then calculates the scoring for the memory and CPU resources following the same logic. Finally, it computes the overall node score by combining the individual scores for each resource type. The code snippet shows the available and used resources on a node, with 8 units of Intel.com/Fu, 1 GB of memory, and 8 CPUs available. The node has used 2 units of Intel.com/Fu, 512 MB of memory, and 6 CPUs, indicating resource utilization on the node. The code calculates the node score for a node based on the resource allocation and utilization of Intel.com/Fu memory, and CPU. It applies a resource scoring function to determine the score for each resource type, then combines these scores to calculate the overall node score. Finally, it divides the sum of individual resource scores by the total weight of the resources to get the final node score of 7. The requested-to-capacity ratio strategy allows users to allocate resources with specified weights, optimizing node allocation by assessing the requested capacity ratio. Users can enhance the utilization of scarce resources in large clusters, enabling efficient bin packing by setting parameters accordingly. Node preference is determined by the allocated resources function, adjustable via the scoring strategy field to manage requested-to-capacity ratio behavior. Within this field, the parameters requesting resources are customizable, such as most requested based on utilization and score values. The resources parameter includes the name and weight of resources, with optional configuration for extended resources like Intel.com/Fu and Intel.com/Bar. Scoring assigns a node a score of 0 for 0% utilization and 10 for full utilization. Adjustments can favor least requested resources by reversing scores. Weights default to 1 and can't be negative.